Hi, everybody. It's Monday, May 4th. Um, this is the second to last lecture of the course. A little bit late getting to you. Your projects are starting to show up now, and some of them are incredibly good. I'm getting totally blown away. I wanted to give you, just as a second to last lecture, kind of an idea of what I would have hoped to have done had we had more time in this remote version of what I was going to do during the year. Second to last lecture. Uh, I like to always, at the end of Physics 112, talk about some special topics course. And this year, given the fact that so many of you are in the healthcare area, I was going to talk about these kind of things. ECGs or EKGs. That's the one thing I'm going to show you today. I was going to talk to you a little bit about electroencephalograms with an emphasis on biofeedback. This is an area that I have had an interest in since back in the 90s when I worked with a group in the biomedical engineering group at University of Wisconsin. I'm not going to show you about that. I was going to talk to you about autonomous drone sensors and an example of AI computer vision, some other things. Not going to do that. Sorry about that. I want to talk to you about EKGs, and along the way, I want to talk to you about impedance pneumography. This is a standard pneumography technique where you want to measure the respiration rate of a patient. Okay, and this is an old, very old historical document, right? Where there's a kind of a strain gauge sensor, and people still use that. You can also use spirometers, which measure the airflow of your nostril to measure respiration. Impedance pneumography is the implementation that I'm going to show you today in this little do-it-yourself home respiration EKG oxygen saturation measurement device. You essentially measure the resistance of your chest cavity, and from Ohm's law, you can infer the enumeration rate. Here's how it works. The implementation that I'm going to show you has only 2 electrodes. There are also 4 electrode ways to do that. Okay, here's the chest cavity. You put an electrode here, an electrode here, measure the resistance between this electrode and that one with a constant current source, happens to be an AC course, measure the AC voltage. A slightly better way to do that is using the 4-probe method. The interesting thing about that is as soon as I heard about electrical impedance pneumography, I knew exactly what they were talking about, because this is a very, well, here's the model for it. Kind of looking familiar things. Here's a 4-probe measurement for measuring the semiconductor doping profile of an ion implantation silicon wafer, a topic that used to be a subject near and dear to my heart back in the old days. 4-point probe, you drive a current here, you measure the voltage here, and that's a standard technique for measuring dopant concentrations in a silicon wafer. My group at Wisconsin did some work on that. Here's what I'm going to show you. I'm going to show you an open source vital sign monitor using the Raspberry Pi. This was a crowd-funded activity, and here's the device I'll show you. It's a Raspberry Pi buried inside here and a little LCD display, and it can measure primitive measurement of the EKG or ECG, your oxygen rate and your respiration rate, also your temperature. You can also add some other things, but the implementation I'm going to show you is just this simple. Here's what you can measure: the ECG or the EKG, the respiration rate, your oxygen concentration, and your skin temperature. Here are the electrode configurations for that measurement. It's not the standard configuration. This placement here gives you optimal measurements of the chest resistivity across the diaphragm. I mean, this is kind of interesting to me given the current COVID-19 situation. There's a lot of groups in the field. Doctors Without Borders, Médecins Sans Frontières, is using little tools like this in the field because the gadget I'm going to show you can run off of a little portable battery for days at a time in the field without even any power mains. So, and of course, if you look online, you see that Amazon people are buying out oxygen spirometer, oxygen concentration writes fingertip things because people are worried about their oxygen content. So kind of interesting. So here, let me show you what you can measure with a tool like this. So here's the Raspberry Pi Healthy Pi hat combination. Here's the Raspberry Pi, which is buried inside the display right underneath the hat here. This is what a Raspberry Pi looks like. It's a pretty powerful little Cortex microcomputer. Here's the Healthy Pi hat, which you can run with a Raspberry Pi or just with your laptop too. The hat itself is only about $100 or so. These are the sensors. Here's the ECG sensors. Here's the fingertip oxygen sensor, and here's a peripheral temperature sensor. There's the responding to my temperature. Here's the oxygen sensor. 95% oxygen, so I'm alive. That's a good sign. So here's my heart rate, 73 beats per minute from the EKG. My respiration rate from the pneumograph, 26 respirations per minute. Now I'm going to start breathing faster, hyperventilate. 23. 38. Takes some time for the average roll. 46 respiration, averaging up faster. Coming down again. So that's the story for this special topic. There will be one final lecture that I will post, one video that I'll post, which will kind of be a final farewell and kind of rehash of the projects and grading kind of things, and a kind of a wish to you for a good summer and a good future. That'll be the last video I'll post. That'll be posted in a couple of days. See you in a bit.